Okay, so next we discuss a couple of tools for bugging. So one is the error estimation. So how to maximize the out-of-sample performance, I mean the test performance. So we use the out-of-back error estimation. So this is unique for this bugging. So in each tree created in a bugging, the unused observations are called out-of-back observations. Okay, so yeah, you can see that, for example, suppose we have 6 observations here, then the bootstrapped sample is 513235. So this is 6 observations with replacement. Then some of the observations do not appear in this set. So that is actually, in this case, 4 and 6. So this is OOB, so out of sample, sorry, the out of bag observations. So if we create a tree based on this training set, the cross-validated set, sorry, the bootstrapped set, and then we test with this OBB observations, then this is basically the mimic to cross-validation. So if we use the OOB observations as the test set to evaluate the error size, then this corresponds to out-of-sample performance. And we make many trees in bugging, so typically maybe 100 times. So we make this error size for each of 100 trees and take average. So that is usually a good measure of test performance. So that is the idea of out-of-bag error estimation. So this is a figure to explain the how out-of-bag error works. And okay, so at first, this black one is, oh sorry, the blue one. So blue one is the error size, the estimated error size with the out-of-bag observations. So you can see that the for the number of trees increases, then we get a better performance, and actually so number of trees increases, then it gets better and better, but it becomes stable maybe around here, maybe after the tree size gets 40. Yeah, so this is the expected size of the test error or something. But actually, if we create another test set and we evaluate it, then actually the test performance is much worse. So this is a little bit interesting feature. So out-of-bag performance is almost the same thing as cross-validation performance, and we expect this is almost comparable to the test performance, but actually often this OOB error size is smaller than the test error. So so anyway, so OOB error is used as a good measure, but still we have some trouble to underestimate the test error. Yeah, so the next tool is the variable importance measures. So one problem in bugging is interpretation. So if we use one tree, it's pretty intuitive. So we can split with some variable, with some threshold. It's very specific. But after taking average, it's really harder to interpret it. So we need some interpretation of the results. And the one good measure is the variable importance measure. So importance of each predictor in bugging is represented by how much the variable decreases an error size. So for example, if we use the sum of squared errors for regression, then we can evaluate each variable, how much each variable decrease the sum of squared errors. And this is standardized, so this variable decrease the error size most, so we make it as 100. And we can compare some other variables. So if we drop other variables, how much the RSS, the sum of the squared residuals gets worse. Okay, so the improvement in RSS is represented by this this graph. So the SAL, the THAL variable is most important, and the CA variable is next important, and so on. Probably these variables are not as important as these variables. So these are the basic ideas for bugging. Okay, so see you then.